Welcome everybody to the next episode of Voices of Sample Management. Today we were thinking about having a topic on machine learning and artificial intelligence, always a very hot topic in the media. But how does that affect sample management and even a software company such as Mosaic in their software development moving forward? To help me with that, I've asked Gergely Bandi to join me. Gergely, could you introduce yourself?
Hi, everyone. I'm Gergely Bandi. I'm originally from Hungary, and I'm the head of software development of the UK team for Titian. Before joining Titian, I've done a PhD in virtual living organisms. So that was actually quite related to this topic. Before that, I've done other software development. And at Titian, I started being a software engineer, and then went from there up to now becoming the head of software development for the past 5 or 7 years.
And enjoyed every moment of it, no doubt.
Yeah, it was great. It was great. Yeah, Titian was a great place.
Okay, so I suppose we should really start off at the very basics. There's the terminology machine learning and artificial intelligence, and it seems to encompass, whether you've been watching Terminator films or all the way down to, speaking to your telephone. Could you sort of summarize what the terms mean?
Yeah. So let's start with the broader one, the artificial intelligence, which is usually very loosely defined. There are many definitions for it. The one I actually like the best is based on the task at hand. So that goes like artificial intelligence is where you apply software solution to a problem that doesn't have a satisfactory software solution available until now, which is great because we're moving ahead. So last year's artificial intelligence is today's sort of minimum requirement for any phone that you have in your hand. So we had artificial intelligence in playing chess on an average level. That's no longer artificial intelligence. That's a game. We had optical character recognition. We had voice transcription. We had barcode scanning. All of these things that used to be AI when they were cutting edge. And now they're just sort of everyday software. So we're moving on, and AI is the next thing that we are working on. So it's everywhere, because whatever you're doing on your phone in your lab, it used to be AI at one point. So the way the liquid handler heads move and calculate the optimal way of doing their work, the way the two position verifiers use image recognition to verify the positions. That's all AI, or used to be AI, and then we're making them even better with new AI practically. Machine learning is sort of a subset where you use data set, past data set, to do classifications, predictions. So it's practically learning from large data to be able to sort of predict the future or the outcome of new data that it's getting. So that's what machine learning is. It has many types available, and again, it's something that's used in many places. I think one of the big successes of machine learning is image recognition, voice recognition. These were very early versions of it, and we managed to make it work well sort of decade ago. So it's a good stuff, and again, it's one of these sort of main pillars of AI as we have it today.
And you see that in rack scanners, and even our newly released
exactly
voice weighing application.
Exactly.
Just you can use these technologies because they now have been developed.
Yes.
Right. Okay. So I suppose moving on, how does machine? How can you see maybe machine learning being used at in a software application such as Mosaic?
So again, it was niche at one point. Then we had a few solutions for sort of typical problems that were used in those types of software. And now we're at the point where machine learning is so widely available in so easy ways that wherever you have access to past data and you're really interested in something being classified or predicted, then you can use machine learning there. So it's really find a spot where you could use that sort of outcome prediction and just put machine learning there. So you can use it in small to large areas. So you can predict how long an order fulfillment would take. You can predict it at a machine level. You can predict maintenance. So that's one thing that they're using now is predict when maintenance will be needed based on past breakdowns and such. So you can sort of see that you're safer this week than you're going to be next based on past data, and it does work. So yes, it's everywhere. This one is everywhere now, I think.
Okay, so but I suppose I've heard that machine learning needs good, clean data in order to make good predictions.
Yes. So it helps if you have a large amount of data to train it on. Otherwise, you can do sort of supervised training where you're just saying this is right, this is wrong, this is dog, this is cat. But even in that case, the more data you have, the more useful it will become. And in that case, it's a bit harder to get to the point because you have to put in all the effort of training it. While you can do an unsupervised version where you just have a large data set of this is how long these orders took based on whatever information. This is how often these machines broke down based on their type, and then it can just calculate it based on that.
Okay, and I'm guessing Titian, as a software company, is looking into proofs of concept on that.
Yes, exactly. We're doing sort of multiple. We have multiple ideas of how we can best utilize this, and we're working on this at the moment.
Okay, cool. So you're head of UK software development. How does all this technology help software development moving forward?
So there are multiple ways, especially generative AI is used in software development. It can generate sort of the plumbing, the fixtures for your code. So you write a code. Writing code is very hard. Writing good code is incredibly hard, and it's supported by lots of automated tests. It's supported by lots of infrastructure to make sure it works well and reliable. And AI is very good at writing these tests, the documentation, so these parts of the code. AI can now also write, generative AI can now also write code, and people do use that with sort of mixed level of success. So while it can write a lot of code, it cannot write a lot of good code. So all the data that we have today shows that all the code that AI writes is far more likely to be rewritten in the next 2 years than those that human write. So, it means that it can help, it can give you a boost, but it will worsen the quality of your products. Hence, use it wisely and use it at the right places.
Okay, so I mean, can it be used for the foundations, but then a human developer needs to take over, or is it the advice at the moment? Tread with care.
Well, yes, tread with care and always sort of review what it does. So it can create lots of automated test scenarios, test cases for your code. That's very good at, and then you can review and add on as needed. So these type of things are very useful and used throughout.
But it doesn't sound like yet it's going to replace every software developer in the world. With...
No, not in the near future. Yeah. So there are places where AI will, and there's been very good research into that. So there's been an MIT research earlier this year that especially looked at image recognition-based tasks and how AI could replace humans or augment humans in a cost-effective way. I guess cost-effectiveness is very important, at least at this time. And the thing they found is that AI can help with, I think, around 25% of visual-based jobs, but only 3% of visual-based tasks in a cost-efficient manner. And that's because it's not easy to install those sort of image processing instruments at the right place at the right time. It's not enough to be 80% confident in the results, and these will all increase in the future. So they predict that by the end of the decade, AI will be able to do 40% of the visual-based tasks, and that's sort of what I see across the board. So it will always help developers. It will help developers do the task that just takes time and not much sort of mental effort, and that's where it's good. So you can concentrate more on getting the right architecture, getting the right design to make it future-proof, while AI will do the sort of nitty-gritty details of the coding that is just practically using your fingers afterwards.
Right. Okay. So, I mean, in some ways, it's equivalent to classic sample management starting to automate your lab. It's starting to automate the software development, but doesn't replace the people. It allows the people to do more useful work.
Exactly. So you're not sort of spending your time moving plates between machines. You're actually sort of designing the workflow of what you're doing and making sure that you get the right result with the right quality as needed.
Oh, okay. So what do you think's the exciting new thing that's going to be coming through? We all hear about ChatGPT and the latest thing from Google, which has a few issues at the moment, I understand, mainly because they're trying to put rules on top of something that is supposed to be ruleless.
Yes.
Which is an interesting problem. But what's new and fascinating coming in the future?
Well, I guess it will more be what the effect is on our lives, rather than what will come. So as everyone says, I'm quite afraid of sort of fake news type things, which is now incredibly easy to do. Some of these systems have built-in safeguards against it, but there are lots of local solutions for this. So I on my laptop I can generate images, videos, or text with my own local AIs here, and I make the rules for them. so the fact that you cannot use ChatGPT to create sort of false news with false images doesn't mean that you cannot do the same locally. So if someone wants to, they can. They now have the tools. So I suspect that will affect our lives greatly.
Could you have an artificial intelligence system to look out for artificial intelligence created news?
Yes. It is an active part of research at the moment, and there are tools to sort of spot that. I suspect it will be harder and harder to do so.
Yeah.
And I guess it will go into the impossible level. So it will be a threat on that front.
Okay.
But I suspect much less so in our jobs. So as we talked about, I think it will augment what we do. It will make us be more productive because we can do more of what matters, and then it can sort of do the rest. Which probably means that people will need to be slightly more trained, specialized to use their minds the way that actually gets the value out of people, because they will be able to do more. So in terms of software development, that means that we can write more software with the same amount of people, so we can put more features out. It doesn't mean that we're, it's going to take less people to do what we're doing. It just means that we will be able to do more for our customers than before. And
so the pipeline becomes quicker rather than
exactly
disappear. Yeah. Okay.
Yes. So there's not a finite amount of work. That's something that sometimes crosses people's mind. There's no finite amount of work. There's just finite amount of output and effort you can put into it. So that's what the Industrial Revolution showed us, that all the things that got automated didn't mean that people cannot really do work. It's just that they can do more and produce more with the same amount of work. So I don't think we need to fear about that part. And again, in the lab, people already know, because a lot of things have been automated. A lot of things Mosaic has automated and improved, and it just means that they can actually do more work rather than needing fewer people.
Okay, cool. Thank you. I haven't got anything else to add. I think that's a good little chat. Thank you very much, Gergely.
Right, happy to help.
Cheers. Bye-bye.
Bye.
And thank you everybody for listening in.